2003 National Electrical Code, commonly referred to as the NEC, does not introduce a change prohibiting the use of grey conductors as neutral conductors. The assertion that grey cannot be used as a neutral, according to the 2003 NEC, is incorrect. Grey conductors are permitted for use as neutral conductors under the guidelines established in the 2003 NEC. In the 2003 NEC, Article 310.12 is the specific section that references grey conductors. This article outlines the requirements for identifying conductors used as neutral conductors. It states that conductors serving as neutrals must be identifiable by their color, either white or natural grey, or through a continuous white stripe applied to conductors that are not green, red, black, purple, orange, or yellow. It is crucial to understand that Article 310.12 does not restrict the use of grey conductors for neutral purposes. Instead, it focuses on ensuring that neutral conductors, including those that are grey, are properly identified to prevent confusion and ensure safety. The code mandates clear identification of neutral conductors through color or striping. This identification is essential for distinguishing neutral conductors from other types of conductors such as phase conductors, which carry electrical current, and grounding conductors, which provide a path for fault current to return to the source. The proper identification of neutral conductors is a fundamental safety measure in electrical installations. It helps to prevent accidental connections that could lead to electrical shock, equipment damage, or fire hazards. By requiring neutral conductors to be identified by color or striping, the NEC aims to minimize the risk of errors during installation and maintenance. The use of white or natural grey as the primary colors for neutral conductors is a long-standing practice in electrical wiring. This color convention is widely recognized and understood by electricians and other qualified personnel. The option to use a continuous white stripe on conductors of other colors, excluding green, red, black, purple, orange, or yellow, provides flexibility in situations where white or grey conductors are not readily available or where other color coding schemes are in use. This allowance ensures that neutral conductors can be reliably identified regardless of the specific circumstances. The NEC emphasis on clear and consistent identification of neutral conductors reflects the importance of safety in electrical work. By adhering to the requirements outlined in Article 310.12 and other relevant sections of the Code, electricians and other professionals can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. Therefore, the statement that the 2003 NEC prohibits the use of grey conductors as neutrals is a misinterpretation of the Code. The 2003 NEC permits the use of grey conductors as neutrals provided that they are properly identified in accordance with Article 310.12a. The main objective of this code is to ensure safety and prevent errors by mandating a clear identification of neutral conductors. To further clarify, let's discuss some key aspects of neutral conductors and their role in electrical systems. A neutral conductor is a part of an electrical circuit that carries current back to the source. In a typical alternating current (AC) power system, the neutral conductor is connected to the neutral point of the source, which is usually grounded. This grounding provides a reference point for the voltage in the system and helps to stabilize the voltage levels. The neutral conductor plays a crucial role in balancing the current flow in a three-phase system. In a balanced three-phase system, the currents in the three phases are equal in magnitude and 120 degrees apart in phase angle. The neutral conductor carries any unbalanced current that may be present in the system. If the loads in the three phases are not perfectly balanced, the neutral conductor will carry a current that is equal to the vector sum of the currents in the three phases. In a single-phase system, the neutral conductor carries the return current from the load back to the source. The current in the neutral conductor is equal to the current in the phase conductor. The size of the neutral conductor is typically the same as the size of the phase conductor in a single-phase system. However, in some cases, the neutral conductor may be smaller than the phase conductor depending on the type of load and the applicable codes and standards. The identification of neutral conductors is essential for safety and proper operation of electrical systems. The NEC requires that neutral conductors be identified by their color, either white or natural gray, or by a continuous white stripe on conductors of other colors, excluding green, red, black, purple, orange, or yellow. This color coding helps to prevent accidental connections that could lead to electrical shock, equipment damage, or fire hazards. The use of gray as a neutral conductor is permitted under the NEC, but it is important to ensure that the gray conductor is clearly identified as a neutral conductor. This can be done by marking the conductor with white tape or paint at all termination points. It is also important to follow all other applicable codes and standards when installing electrical systems, including those related to grounding, bonding, and overcurrent protection. Grounding and bonding are two important concepts in electrical safety. Grounding refers to the connection of electrical equipment to the earth. Grounding helps to protect against electrical shock by providing a path for fault current to return to the source. Bonding refers to the connection of different metal parts of an electrical system together. Bonding helps to equalize the voltage between different metal parts, which reduces the risk of electrical shock. Overcurrent protection is another important safety measure in electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect against overloads and short circuits. Overloads occur when the current in a circuit exceeds the rated capacity of the circuit. Short circuits occur when there is a direct connection between two conductors in a circuit. Overcurrent protection devices interrupt the flow of current in a circuit when an overload or short circuit occurs, which helps to prevent equipment damage and fire hazards. In addition to the NEC, other codes and standards may apply to electrical installations. These codes and standards may vary depending on the location and the type of installation. It is important to be familiar with all applicable codes and standards before beginning any electrical work. The NEC is a comprehensive set of rules and regulations that govern the installation and maintenance of electrical systems. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not a law, but it is widely adopted by state and local jurisdictions as a basis for their electrical codes. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. The NEC covers a wide range of topics, including wiring methods, grounding, bonding, overcurrent protection, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections. Chapters cover broad topics such as general requirements and wiring methods. Articles cover specific topics within each chapter, such as grounding and bonding. Sections provide detailed requirements for each topic. The NEC is a complex document, but it is essential for anyone who works with electrical systems to be familiar with its provisions. The NEC is available for purchase from the National Fire Protection Association, NFPA, and other sources. It is also available online through various subscription services. In addition to the NEC, other resources are available to help electricians and other professionals stay up to date on the latest codes and standards. These resources include training courses, seminars, and publications. It is important to continuously update your knowledge of electrical codes and standards to ensure that you are providing safe and reliable electrical services. Let's delve deeper into Article 310.12 and its implications for neutral conductor identification. The specific wording of Article 310.12 is crucial to understanding its requirements. As previously mentioned, it states that conductors used as neutral conductors shall be identified by white or natural grey color or by a continuous white stripe on other than green, red, black, purple, orange, or yellow. This seemingly simple sentence contains several important details that are worth exploring. Firstly, the phrase conductors used as neutral conductors makes it clear that this requirement applies specifically to conductors that are intended to serve as neutrals. It does not apply to conductors that are used for other purposes, such as phase conductors or grounding conductors. Secondly, the phrase shall be identified indicates that this is a mandatory requirement. In other words, it is not optional to identify neutral conductors in accordance with this article. The NEC uses the word "shall" to indicate requirements that are mandatory and must be followed. Thirdly, the phrase white or natural grey colours specifies the primary colours that are permitted for neutral conductors. White is the most common colour used for neutral conductors in North America. Natural grey is also permitted, but it is less commonly used. Fourthly, the phrase "or by a continuous white stripe on other than green, red, black, purple, orange, or yellow" provides an alternative method for identifying neutral conductors. This alternative method is permitted for conductors that are not white or natural grey, but it is subject to certain restrictions. Specifically, the conductor must not be green, red, black, purple, orange, or yellow. These colors are reserved for other purposes, such as grounding conductors and phase conductors. The continuous white stripe must be applied along the entire length of the conductor. The stripe must be clearly visible and easily identifiable. The purpose of the continuous white stripe is to provide a clear and unambiguous indication that the conductor is being used as a neutral conductor. The NEC also includes requirements for the size and type of conductors that can be used as neutral conductors. These requirements vary depending on the application and the voltage of the system. In general, the neutral conductor must be sized to carry the maximum unbalanced current that is likely to flow in the system. The neutral conductor must also be suitable for the environmental conditions in which it is installed. For example, if the conductor is installed in a wet location, it must be listed for wet locations. The NEC also includes requirements for the termination of neutral conductors. These requirements are designed to ensure that the neutral conductor is properly connected to the electrical system and that the connection is safe and reliable. In general, the neutral conductor must be terminated in a manner that prevents it from becoming loose or disconnected. The neutral conductor must also be protected from corrosion and other forms of damage. The NEC also includes requirements for the grounding of neutral conductors. These requirements were designed to ensure that the neutral conductor is properly grounded to the earth. Grounding the neutral conductor helps to stabilize the voltage in the system and to protect against electrical shock. In general, the neutral conductor must be grounded at the service entrance and at other points in the system as required by the NEC. The NEC is a complex and comprehensive document, but it is essential for anyone who works with electrical systems to be familiar with its provisions. By following the requirements of the NEC, electricians and other professionals can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. In summary, the 2003 NEC does not prohibit the use of grey conductors as neutral conductors. Article 310.12 permits the use of grey conductors as neutrals, provided that they are properly identified in accordance with the requirements of the article. The NEC emphasis on clear and consistent identification of neutral conductors reflects the importance of safety in electrical work.